But welcome to this UNGEGN webinar series. This is the second one we are having, and today's subject is developing digital gazetteers using free and open software. This is going to run for an hour and a half, and I'll just present myself. I am Peter Gammeltoft. I am the scientific manager of the Norwegian language collections. It also says here I'm a librarian. That's formally correct, but I've hardly seen a book for the last 4 years because I'm working on the digital side of things mainly. I'm also the chair or the convener of the UNGEGN working group on toponymic training, and also the convener on the working group on publicity and funding. And then this is in that respect I'm sitting here today. But I will not take more than necessary time off you. I will hand over to Pierre Chayar, our chair at UNGEGN. Pierre Chayar has worked for the Ministry of the Economy for over 30 years, apart from a little spell at the Court of Auditors. He has chaired the French Commission on Toponymy for 17 years, and he is also, among other things, vice president of the Association of Patrimoine Sans Frontières, Cultural Heritage Without Borders, for those of you that are not that good in French. And he has also been the deputy manager, mayor in charge of cultural action. But he is here in the capacity of chair. So please, Pierre, I will give the floor to you, and I will stop sharing, and so you can all see Pierre.
Thank you. Thank you, Peter. Well, dear colleagues and friends, I'm very impressed of the number of you connected to this webinar. I'm pleased to welcome you for this webinar. As you know, since you have registered, this webinar will focus on the development of Gazetteers using free and open software, as well as Gazetteers web services and applications for the management, visualization, and dissemination of geographical names. Our strategic aim is to raise awareness and build capacity on the use of technology and innovation within the UNGEGN community. In particular, our today's goal is to show that everyone can achieve a professional level of performance with freely available tools and without dependence on the private suppliers. I would like to thank in advance each of the experts who have agreed to share their experience and expertise in this webinar, either as a presenter or as a moderator. I rely on their technical expertise and teaching ability to make this webinar fully useful to all of us. Thank you for your attention.
Thank you very much, Pierre. Thank you for the nice welcome. We have another opening remarker, and this is our Stefan Sveinfest, who's the director of the statistics division under which UNGEGN is placed. And Stefan has a long career in the statistics division, which he joined in 1989. And he has been the substantive secretary of 3 intergovernmental bodies, the United Nations Statistical Commission since 2002, and the UNGEGN since 2011, and the United Nations Committee on Experts on Global Geospatial Information and Management, also known as UNGEGN. And I will just give the floor to Stefan. I hope Stefan, is your camera working or still now, or shall I just keep this up?
Thanks, Peter. I think if you could just keep this up. Can you hear me?
Oh, sorry. Yeah, we can hear you fine.
Yeah, no, okay. Good morning, everybody from New York. It's a beautiful morning in New York. My apologies. I'm struggling with my computer, and it suddenly decided that there's no camera available. Yesterday it had a camera, so I don't know what happened overnight. But I better don't go into the settings because terrible things might happen. So I'll just talk to you. I'm very happy to welcome you to this webinar, and I'm really truly impressed. I think by now we have passed the 100 mark. I'm a statistician after all, looking at the numbers. So this is really impressive. I think UNGEGN, one of the reasons I really like to work with UNGEGN, and I always have, and I have now probably 20 years of experience in that, is the true dedication of people all around the world, and that are coming together as a professional community. And that's what you're doing this morning with this webinar. We are in an official rhythm of meeting every 2 years. So that's the odd years. So we are actually between two official meetings. We will meet again, I hope, in New York personally in exactly 1 year from now in May 2023. And I'm certainly very much looking forward to this. Today, this webinar is getting us together as a professional community on a very important topic. Pierre already introduced it. Gazetteers are critically important for UNGEGN and have been a topic since the very beginning. And we are doing here what we are doing best at the United Nations. We are bringing people from all over the world together, and we are sharing experiences from 3 different continents, from Brazil, from Europe, and from New Zealand. So I'm very excited to hearing from the colleagues. And this is, of course, part of the new strategic plan and program of work from 2021 to 2029, which the leaders of the UNGEGN group have developed. So I'm looking forward to many, many more similar opportunities. Gazetteers I found always very fascinating because, of course, there are a data set, an important data set of geographical names that help us to manage a country, to manage the development. They are critically important, for instance, in a humanitarian crisis, to have a comprehensive accounting of all the names. But they are also documentation of the history and the cultural identity of people. So I think they are really at the heart of your work. So I'm very much looking forward to this event, and I would like to thank everybody, the leadership of UNGEGN under Pierre's leadership, Peter, who is leading the event today, my own staff, Cecile, who have been tirelessly working of bringing this together. Thank you very much.
Thank you very much, Stefan. And now we go on to the main event, and that is the actual webinar. And I would just like to remind you of the meeting guidelines. And I have already touched on number 1. Please remember to keep your microphones muted during the presentations. And when we have finished all the presentations and we go to the discussions, please, if you want to ask a question or say a remark or something like that, please use the raise hand button. And that is, there's like a little smiley guy with a hand that says reactions, I think it is in English. And there's the flat hand is the one you raise to indicate you want to communicate. And we will do our very best to keep up with the order and the line of hands. You can also use the chat if you have thoughts you want to communicate, but not necessarily want to speak out to everyone, or if it's part or agreement with a comment or question or something like that. If you speak to other participants in the chat, then there is a private chat channel to use that may be the most convenient for you. And although some of us are quite nosy persons, it's probably best that we don't know everything that's being said. And please be aware that this webinar is being recorded. I will then go on to presenting all the presenters first, and then we will go on to the first presentation after that. The program is as such. First, we have the contribution from Brazil. Then we have from the contribution from Germany, and then last from New Zealand. And then for the last 20 minutes, we will have questions and discussions, and then there'll be some closing remarks. But on to our speakers. We have all four here. Let's see if I can. Juggling between all these screens is a little difficult now and again. No, that's not the one. As you can see, I'm not finding it easy today. Let's see here. There we are. Today's first speakers are from Brazil, as you saw. It's Graciosa Moreira and Viviane Diniz. Graciosa has a Master of Science degree. Just turn onto the page. In education from Universidade Estácio de Sá in Rio de Janeiro in Brazil, and a PhD in intellectual property and innovation from the Instituto Nacional de Propriedade Intelectual, and that is the National Institute for Intellectual Property in Brazil. But the last 17 years, she has been working with the development of toponymic data files in the Geographical Names Department of the Coordination of Geodesy and Cartography of the Brazilian Institute of Geography and Statistics, also known as IBGE. Viviane Diniz is a Bachelor of Science in Computer Science from the Universidade Federal Fluminense, Brazil, and the Master of Science degree in Informatics from the Universidade Federal de Rio de Janeiro, also in Brazil. And Viviane has also, the last 17 years, been working with the development of geospatial databases and solutions for cartographic production at IBGE. And their production is titled Development of Electronic Gazetteers Using Open Source Software. The next speaker we will hear from is Piergiorgio Sacadou, that many of us know, but he has 20 years experience in the field of geospatial information at the Federal Agency for Cartography and Geodesy, and he's the Vice President of the Permanent Committee of the Standardization of Geographical Names for the German-speaking countries. And he is, of course, representing Germany there. And this is in UNGEGN. And he's also a convener of the Working Group on Geographical Names Data Management at UNGEGN. Piergiorgio is currently the chair of the UNGEGN Europe Working Group on Data Integration, but has previously been one of the key figures in the implementation of spatial data infrastructure in Germany and in the work related to the INSPIRE initiative in Europe. And his presentation will, as far as I can see, relate to this work. And it's titled An Open Regional Gazetteer for Europe, Challenges and Opportunities. And our third and last speaker is Christopher Stevens, who is an advisor to the New Zealand Geographic Board, Ngā Po Tanuaha o Aotearoa, New Zealand's national place naming authority. He has a bachelor degree in history and classical studies and art history from Victoria University of Wellington in New Zealand, and he has developed skills in GIS and information management throughout his professional career. Christopher is particularly interested in improving the New Zealand Gazetteers and to encourage reuse and spatial linking information, also reflected in the title of his presentation, which is Development and Use of an Electronic Gazetteer. But I think we will, sorry, here I have all these bios that I forgot to show you all, but we will go on to the first presentation. I'll just go back to here, which is development of electronic gazetteers using open source softwares, gazetteers with Brazilian base maps. And then I will just stop sharing, and then Gracios and Viviane can do their presentation.
Thank you for the opportunity to participate in this webinar.
Hello, everyone. My name is Viviane, and I work for the Brazilian Institute of Geography and Statistics, the IBGE. My colleague, Gracios, and I are going to present you how the IBGE Gazetteers have been produced using open source software. Our professional skills involve business-related IT activities like producing data models, system requirements specifications, and also some developing in database programming language and Python for QGIS. First of all, Brazil has no National Geographical Names Authority, so we have no national gazetteer. The IBGE produces gazetteers of our own base maps. Names can be found in different form in maps by other institutions, for example. The IBGE holds a seat in UNGEGN representing Brazil and is vice chair of the Portuguese-speaking division, and is the only one of the institutions responsible for the authoritative mapping of the country, which does research, treats, produces, and disseminates toponymic information for the society in general. And we do it according to UNGEGN resolutions. We are the only mapping agency to produce gazetteers. As an official mapping agency, the IBGE participates, as well as other mapping institutions, in the establishment of norms, standards, and specifications for geospatial data production, management, and dissemination. Our gazetteers are strongly linked to the process of producing cartographic data. In fact, they are extracted from the cartographic database. We highlight two initiatives that had effects on the Brazilian gazetteers. The first is the Brazilian SDI, Spatial Data Infrastructure, the INDI. The legal framework for the INDI defines it as an integrated set of technologies, policies, coordination, and monitoring mechanisms and procedures, standards, and agreements necessary to facilitate and order the generation, storage, access, sharing, dissemination, and use of geospatial data of federal, state, districtal, and municipal origin, a big scope. The IBGE is responsible for the maintenance of the INDI web portal and is the manager of the geospatial data directory. It includes geoservices and metadata catalogs, besides a map visualization portal and data download services. Every geospatial data produced in IBGE is available in the IndieWeb portal as geoservices and their associated metadata or as download files. Brazilia's Gazetteers have been included last year. Before that, they were made available in the IBGE website. The other standard had a deep effect in the way Brazilian gazetteers are produced. It is the specification for structuring the geospatial vector data in Brazil, in Brazilian initials IBGE. This specification was a collective construction by institutions involved in mapping efforts and is intended to standardize authoritative cartography and to make sharing easier through a common understanding of geographical features. It consists of a conceptual model. In fact, it is a set of object-oriented models that expresses geographical features and their associations. These models are grouped into categories or packages. Each category or package includes classes related to the category subject. The IBGE Cartographic Production Database is an implementation of this specification. So, this is the highest level model in IBGE 3.0 specification. Packages or categories. As I mentioned, there are class models in each one. All models together have hundreds of classes, and not all are suitable for all scales. The IBGE itself has a table showing which classes are suitable for each scale. Also, the IBGE has an internal specification which points classes to implement according to our business. Here is a very short picture of hydrography package. Just an illustration. We have implemented classes that are not here, but these are certainly very important classes in our business. That is a convention. Yellow classes are package related and the white ones are from other package, just to show the associations. We see body of water, drainage stretch, and island. The model tells us by the associations that body of water contains drainage stretch and island. Island inherits from natural physiographic element, which was an abstraction created to represent relief elements. An archipelago is an aggregation of islands. In this diagram, we also see the possible geometry type for each class. For example, body of water is area type. So, we have analyzed this conceptual model and created a logical and physical model to implement in a relational database system. The chosen one was Postgres PostGIS, and the software that feeds it is QGIS. Currently, Postgres PostGIS versions are 11.7 and 2.5. The general rule for database implementation of this model was each class becoming a table, exceptions in case of generalizations. Each table is named as follows: category initials plus underscore plus class name plus underscore plus geometry type initial. Example in Portuguese: ID, trecho drenagem linha, which is hydrography, drainage stretch, in linear type. This is a print of the screen users in their cartographic production usually have while they are working. They can visualize both the geographical aspect and the attributes of the features. Geographical names are the most relevant attribute they feed the database, together with other attributes related to geographical names, the source of the name, fieldwork or another geospatial base, and if it is connected to political divisions. The first digital gazetteer was published in 2016, drawing from the cartographical production database we mentioned earlier. So, how did the gazetteers come to life? There was a problem to be solved. There was an old paperback gazetteer issued in 2007 containing the geographical names of the continuous cartographic base map in the millionth scale. And we need the list to address the request of the Society for an Updated Gazetteer. The initial idea was to produce gazetteers drawing from the Brazilian Geographical Names Database, BNGB, which is involved in a process of harmonization of names among the base maps in different scales, which is a long-term process. Also, its conceptual model is very complex and name-focused, which is different from the one of the base maps, which is feature-focused. Each name in the BNGB is to receive a unique identifier regardless of scale, which makes feeding it far more demanding and time-consuming. Also, we knew that not all users of this information were familiar with GIS tools. The solution we found was to produce a gazetteer issued together with each of the base maps produced by IBGE in different scales. This is far less time-consuming and less complex. Updates occur together with the updates of the base maps, whose frequency is defined by cartography department. We decided to make them available in CSV format, which is comparable with Excel, which is not a GIS tool and is familiar to many people, and with open source software like QGIS and others, which are popular applications. Our gazetteers have limitations, of course. The most striking of them all is that not all names were treated and revised by the Geographical Names Department, as we were a very small staff, and we cannot work just as fast as the updates and publications of the base maps. Consequently, there were inconsistencies among the names of the gazetteers. The gazetteers are geographical feature-oriented, and this causes a repetition of names due to the topological model of the layers, especially in hydrography features. The gazetteers published from 2016 to the present moment were the following, as you can see. The smaller scales cover the whole country, and the bigger scales cover parts of the country. This one covers 5 units of the federations, the states of Espírito Santo, Rio Grande do Sul, Sergipe, and the state of Goiás and the capital. The other one covers the state of Rio de Janeiro and the state of Santa Catarina. In 2022, we expect to publish an update and a new gazetteer. The gazetteers are structured as follows: geographical name, IBGE related category, IBGE related class, country, unit of the federation,
Type
of geometry, point, line, or area, latitude, longitude. The gazetteers are an output of PL/PG/SQL function developed by us, which reads the cartographic production database features and calculates a representative coordinate for each one. In case of point features, the coordinates are from the point itself. In case of linear features, the coordinates are the midpoints. And in the case of areas, the coordinates are the centroids. Here is how the gazetteer looks in different formats available. This one is the CSV file available in IBGE website. And the other one is the Gazetteer as a geoservice available in UNGEGN. The Gazetteers may be useful for a lot of things. Recently, the IBGE used it as an input for the preparation of the delimitation of enumeration areas for 2022 census. Also, it can be used as reference for academic work and more. They can be used as an input for research in many different fields, research on native vegetation, for example. If you filter the gazetteers for the word macaúba, for example, a palm tree from which various products are derived, you will see this geographical name with macaúba as specific terms. Here, we searched the gazetteer of the base map in the millionth scale. On the left, you can see the spatial representation of the search, and on the right, the geographical distribution of the macaúba in the Brazilian territory according to a study the occurrence of this tree in Brazil carried out by Embrapa, a Brazilian research institute. They match. We realized it may be possible to identify native vegetation of a given area and maybe restore it if this is the case. Finally, the improvements planned for the gazetteers are: in short term, we intend to add a validated status on the gazetteers for names treated by the Geographical Names Department. This attribute already exists in the production database. The geographical names are being analyzed, but there are many names, and some of them require deeper research. So not all of them are receiving validated status at the moment, but at least people will be aware of that. Also, we intend to make the links for the gazetteers available on the Portuguese-speaking division website, which will be published soon. In long term, we intend to generate the gazetteer drawing from the Brazilian Geographical Names Database web application, which will solve the problem of the repetitions of names. Thank you all for your attention.
Thank you very much, Viviane and Graciosa. It's a very interesting and important presentation you gave there. I will, without further ado, hasten on to the next presenter. We have questions and answers after all the presentations, so I'll just hand over to Pier Giorgio Sacadou, and he will speak on an open regional gazetteer for Europe, challenges and opportunities. Please go ahead, Pier Giorgio.
Thank you very much, Peter. Can you hear me?
We can hear you fine.
And you can see my slides or the referent mode?
This is the referent mode. Yeah.
Okay. Now it should
There
be
we go.
fine.
Fine, yeah.
Okay.
Perfect.
Perfect. So, hello everybody, and thank you very much for providing me with the opportunity to inform you about the European Open Regional Gazetteer, the challenges and the opportunities. I've prepared this presentation together with my colleague Jürgen Spradau. In the following 20 minutes, I will try to explain you our motivation, so the motivation of my agency, BKG, Federal Agency for Cartography and Geodesy, to create a pan-European gazetteer on behalf of a European Association for the National Mapping and Cadastral Agencies called Geographics. And I will then also refer to some challenges and opportunities. I would like to start with some prerequisites we identified in Europe at that time. So it was obvious to us that globally no gazetteer service existed for providing comprehensive authoritative names data. It is clear that there is an open service, geonames.org, that was and is the best option at the moment, but it does not provide authoritative names data for each country on the globe. In Europe, although we have a functioning spatial data infrastructure called with the abbreviation INSPIRE, you can find only a cross-border patchwork through prototypes and national name services. These exist, but as I said, this is patchwork in Europe at the moment. And all previous approaches failed at relying on these INSPIRE, so European Spatial Data Infrastructure compliant services so far. BKG, my institute, supports the UNGEGN since the beginning, and of course also the European associations, Geographics, I mentioned that, and we support also the European Spatial Data Infrastructure and the associated names data activities. These have been our motivation, and yeah. This slide here just indicates that the European situation is somehow special. We have a multilingual and multicultural region, and this is somehow shown on this slide from the National Geographic Germany. The full complexity for Europe becomes obvious if you think about a border crossing line feature like the Danube River. A user who wants to get information on the Danube River would like to start his or her search with his well-known geographical name. So a German might start his search with the German name Donau, and an Hungarian may want to start with Duna, but at the end they would all like to receive the same information on the Danube River. And so within a project called EuroGeonames between 2006 and 2009, that was the first approach, we developed a prototype implementation, which was then INSPIRE compliant, so compliant to the European Spatial Data Infrastructure. It was the first web feature service following open, the standards of the Open Geospatial Consortium. And it provided the national names from the national names server together or linked to some axonyms which were linked by UNGEGN experts at that time. And today we face the situation that
sorry, today we face the situation that there is an open data portal for Europe, and you can get more than 1 million data sets there. And if you focus on geographical names data, and if you focus just on geographical names data for Germany, you can find about 7,500 data sets. And this is, you can imagine, this is not a perfect situation. So a user cannot really evaluate and assess which data set to take for the whole country or which data set to take for a region. And the situation in Europe is similar. And so we started to think about what can we do for Europe to provide authoritative geographical names data. And the starting point for us has been the European Association of the National Mapping and Cadastral Agencies, Geographics, because this association already produces topographic data sets where geographical names from the countries were included. There is a regional map product, a topographic data set of scale 1 to 250,000. You can see that more than 50 countries and territories from more than 30 or 36 data producers are providing data to that. Providing data to several feature types, administrative units, hydrographic features, transport, and so on. Several feature classes are provided, and in total, there are about 930,000 primary and more than 12,000 secondary names in that product for Europe. And we linked this product to another Geographic product, Euro Boundary Map, where all the administrative units for Europe are compiled in a data set of scale 1 to 100,000. And here as well, more than 50 countries provide the information, and it is combined by our federal agency in Germany. So both products are produced on behalf of this European Association at my agency, BKG. Okay, so what did we do? It was a perfect starting point for us that the INSPIRE, so the European Spatial Data Infrastructure, was already in place, and for geographical names, a very complex but very good and detailed data model and data specification was available at that time. So we used the products from Geographics and transferred it into a geographical names database format according to the INSPIRE geographical names data model. And you can see here the INSPIRE ID, so unique identifiers were used. The information was transferred from areas, lines to points mainly. I will show this in a few minutes. And the most relevant feature categories were facilitated as well into this joint and linked geographical names database. This is just one or two slides where the implementation is shown. So as I said, you might have in these European products, some features are area features or line features, and these features affiliated to populated places or railway stations, airports, and so on, were transferred to this geographical names data set for Europe to points. And after having done that, the points with the information, these national data sets were linked then again to exonyms and other variant names by an UNGEGN expert, Roman Stanifertel, who is also listening to us today. So you can see here that for the administrative units, the highest level, the country name for Slovenia, some exonyms are included in the database as well. At the end, to show another example of a complex line feature, here the Rhine River, not the Danube River, but the same principle for this gazetteer as well. So you have these national pieces, these national parts of the Rhine with several geographical names associated to the feature. And within the Open Regional Gazetteer, these are compiled to one complex feature, and this complex feature of the Rhine River is then linked to the exonyms by this UNGEGN expert, as I mentioned. So today we can rely on a open regional gazetteer service, which was published within an Open Maps for Europe project. It covers more than 50 countries. And currently more than 70,000 variant names and exonyms. There is a specific information how we have compiled this information. So specification is available, and also a list of references is available for this specific gazetteer service for Europe. The service itself, or the data, can be used as a web feature service. So according to the former project EuroGeonames, this also is available as a web feature service. You can integrate this into your GIS systems, or you can integrate also a database in GeoPackage format into your environment, your technical environment. So just a few more words on the open source software used. So for the web feature service publication, we used the Degree modules. So Degree is an open source software for spatial data infrastructures. It's of course freely available, and it is designed for rich models and supports also geographic markup language application schemas, which is the case for the Inspire data specification for Europe. And with regard to the database, we use GeoPackage. GeoPackage is also an open standards-based platform, independent, and so on and so forth, compact format for transferring geospatial data. It is based on SQLite, which is a public domain library, also open source. And it is the first open geospatial consortium standard for portable geographical geospatial information format. So it's easy to use, at least that is what our technical experts say to me. But it's somehow easy to use for geographical names in the context of geographical names. Okay, so as a third publication line, apart from the database and the web feature service, we have also an application visualized with a map where you can search for the names. So you can search for the name Brussels, for example, and then all the content related to this German exonym Brüssel is linked to a table for the user, and it is visualized on a European map. But as a last slide, I would like to show you some figures after the Open Regional Gazetteer was launched within Open Maps for Europe. So you can see that in a few months time, more than 400 users were registered, and the data set was downloaded more than 300 times. So it is a very popular new product for the Eurogeographics Association in Europe. And this ends my presentation. Thank you very much. As a last slide, I have also some references listed. So if you are provided with the slides, you will also get the references. Thank you very much.
Thank you very much, Pier Giorgio, and thank you for a very insightful presentation. I will hasten on to our presentation from New Zealand, the last one of the three, and this is being presented by Christopher Stevens, and it's titled Development and Use of an Electronic Gazetteer with Open Source Technologies. Please go ahead.
This is pre-recorded given the timing, so I'll just turn it on.
Peter, there's no sound, at least for me. I
There
don't know
doesn't
if
seem
that
to be any sound. Chris, can you turn on the sound, please? I think
Sure.
it's muted.
Tēnā koutou. Greetings to everyone attending this presentation on the Gazetteer development using open source technologies. My name is Christopher Stevens and I serve as an advisor to the New Zealand Geographic Board Ngā Pou Taunaha o Aotearoa, New Zealand's national place naming authority. We're pleased to present on New Zealand's Gazetteer system, which has now been in place for nearly a decade. This presentation is almost a sequel to Chapter 8 of the UNGEGN Toponymy Manual, written shortly after the system was first released, so perhaps this will give an idea of how far we've come. We're pre-recording given the time difference, but I look forward to answering your questions at the end of this presentation in person. Thank you. The New Zealand Geographic Board Ngā Pou Taunaha o Aotearoa is supported by Toitu Te Whenua Land Information New Zealand, or LINZ, L-I-N-Z for short. This government department is responsible for the governance of property rights, mapping and charting New Zealand, and the collection and distribution of many types of data. The department and the New Zealand government as a whole strongly promote open data and the use of open source technologies. Services, products, and applications are typically freely available to use, and where possible, even to reuse and build upon. For this presentation, I'll cover just a little bit of background, describe our system and each of its parts, and, where possible and where applicable, what open source software and platforms we actually use. I'll briefly share some thoughts on our next steps before providing plenty of time to take any questions. The presentation won't go very far into topics such as the board's jurisdiction, the names actually held in the Gazetteer, and taking note of the time available, not too much on the way of reuse of the data. But we'll be pleased to cover any of this in the question time. Every naming authority will have its own circumstances, background and legacy issues, influencing where they might be placed in their respective governments, what they have jurisdiction over, and the systems they use. Very briefly, the New Zealand Geographic Board is nearing its centenary, with an honorary Geographic Board first established in 1924, legislation for assigning official names in 1946, and with our current legislation dating 2008. In this time, some print gazetteers were published, with a couple of examples shown in the slide from 1948 and 1968. The 1968 Gazetteer probably represents the first attempt to account for all place names in use on New Zealand maps, and decisions of the Geographic Board are marked with an asterisk. However, our current legislation in 2008 was the first to set the legal requirement to maintain and publish a publicly available gazetteer. However, historically, official names were mainly communicated through publication on maps. So, in the mid to late 2000s, the decisions of the board had to be retrospectively compiled along with other official names as used on maps in order to create the first complete place names dataset. A new and comprehensive Gazetteer system was required to manage and communicate official naming decisions, and around 2010, development began on the system. And this is what it looks like, simplified as a model. Planning and development, including all the new software components, took about 3 years from 2010 to 2013, and it was made public in the middle of that year. On the left, the internal parts of the system are comprised of a relational and spatial database integrated with a GIS platform, and on the right, external users mostly see the Gazetteer as the web viewing application, where they can make basic inquiries like, is the name official, what does it mean, and where did it come from? Gazetteer data is also published to a distribution platform, enabling other government agencies and third parties to both download or use the authoritative data as a service. And finally, in the top right, other applications within LINS and elsewhere use the Gazetteer mainly to provide a search function using authoritative official names. The board's decisions are still communicated through products like official topographic maps, but again, the shift is that the names are now data in their own right, and LINS will pick up the official place names from the same distribution platform as everybody else. If there's one thing to point out here with the system diagram, it's that it's reasonably modular. The software and technologies that support each role can be upgraded or replaced, potentially with a limited or at least lessened impact on the other parts. And this is exactly what has happened over the last decade. And open source technology really helps here. Next is an abridged timeline of the system development. While it covers a bit of what I've already said, the main takeaway is that we've been very busy for the last 10 years. We've upgraded or rebuilt different parts of the system as our team capacity and our budget have allowed. First, the public-facing web app was completely rebuilt across 2016 to 18, and then another tranche of major enhancements made in 2019. In 2020, our GIS plugin was completely rewritten for ongoing compatibility. And finally, across 2021 and finished earlier this year, we migrated the database across several software versions and to new hardware. With each of these rebuilds, we also put in place more robust processes and support arrangements, which I'll be touching upon more. So for now, I'll run through the 4 parts of the Gazetteer system and what open source software and technologies they actually use. At the center of the system is a PostgreSQL relational database with the PostGIS software extension for the representation of spatial objects. Both of these pieces of software are open source and supported through an extensive community of users. The database is also secure, supporting various modern authentication protocols, tying in with the department's security policies. And from an administrative point of view, it's easy to set up users. The title slide here is just a basic inquiry joining names to features for names approved under a certain process, and the view is using pgadmin for the visual interface, which is another piece of open source software. This also quickly illustrates how we represent place names in our database. Physical features on the landscape, administrative areas, or any other point in space like a historic site are represented with a unique feature ID. And to each feature, one or more names with their own unique name IDs are joined. Other information is then joined to the relevant part, the feature or the name. Most of our day-to-day work is via that plugin for the GIS platform, which I'll cover next, but we do directly query the database for things like statistics or when we need to make a bulk update. As noted in the timeline, we've just completed a major database migration, taking it from Postgres 8.4 to 12.9 and PostGIS 2.1 to 3.2. It also took the server software from Windows Server 2003 to a modern Linux server, once again, a quintessential open source platform. Such major jumps in versions were very challenging, and this mostly came about because the support arrangements from the original system development were weakly defined. Parallel to the migration itself, actually moving the data was to revise and set out new robust support arrangements. So while Postgres 12 will be in support for a while, we do already need to look at a smaller hop to Postgres 14, and that'll keep us in support for several years. We also now have 3 servers and databases. The second is for a mostly separate and parallel system for testing purposes, also publishing to a separate test web application. And for the third, we took the opportunity to improve our disaster recovery arrangements with an independent recovery server. This is on physically separate hardware in a different population centre from production and synchronised live to production. Backups are also taken periodically. In other words, if the live database fails, we can immediately pick up from recovery. UNGEGN and national naming authorities will know from real-world examples how accurate, authoritative and standardised geographic names are critical to emergency response. So, it's good to know that our own system is a little better placed whether there's a fire or flood or something more drastic like a tsunami or earthquake. On a day-to-day basis, we in the Secretariat supporting the New Zealand Geographic Board almost always have QGIS open, connecting directly to the database through a plugin. QGIS supports SQL database connections. QGIS itself is a powerful open source GIS platform, once again with the backing of an extensive community of users and developers, and this includes LINS and many of its staff. Across LINS, there's widespread use of QGIS, and we take advantage of other plugins and tools developed across the organisation. Here in the title slide, I'm looking at satellite-derived elevation data to verify and update the position of a name. Generally, we use QGIS to see place names in their spatial context, as you might expect, putting them over the top of georeferenced maps and to add other layers of information. We use its tools for analysis, to create new information, and then put that back into the database. And for reporting to the board, we can also export graphics, whether an image of the map or something like an elevation profile. This day-to-day use is relatively superficial, considering the great depth the QGIS platform has to offer through its geospatial tools and through automation. For a relatively common task, like defining the extent of a river, we might typically import and edit existing data created by the LINS topographic team. But if the data doesn't exist, we can go deeper and use the processing tools, such as creating hydrological networks from elevation data. The plugin itself is written in Python with JSON, JavaScript object notation, and again communicates directly with the SQL database. The relevant database tables comprising a name are depicted in a plain text panel where they can then be edited. The plugin comes with a suite of tools that interact with QGIS, and vice versa, native QGIS tools can also interact directly with the geometry stored in the database. The plugin also serves to cover most administrative needs, like creating new tables or new system codes if, say, we needed a new feature type, and to define the user permissions. In other words, the plugin is effectively a GUI, a graphical user interface to the spatial database. In the background, when you click the Save button, it's using SQL statements to make the updates. Part of the idea for integrating the database with QGIS was just to train staff on a single platform, in this case QGIS, within a higher level database administration supported by other experts in the organisation. In terms of the original system development, however, a flaw was that the plugin ended up version locked to QGIS 2.6.1. So as the platform continued to rapidly evolve in great leaps and bounds, we were not reaping the benefits. Many workflows would often involve having two versions of QGIS open. 2.6.1 would often cease rendering all objects when it hit a memory cap. Much like the database, this is because the original support arrangements for things like keeping the software up to date were weakly defined. So, in 2020, LINS committed the resources to upgrade the plugin from QGIS 2 to 3 and Python 2 to Python 3. All the errors and issues were managed through GitHub as a typical DevOps project. And the result is that we're no longer version locked, and as QGIS continues to evolve, we can move along with it. The development did require a significant amount of time from the Secretariat team for testing, but this also served as a future-proofing investment because all the user tests for the plugin's functions were automated. Should future versions of QGIS again become incompatible, we should be able to identify at what point the plugin has failed to shorten any future development. Moving across to the external-facing part of the system, the New Zealand Gazetteer for the general public's intents and purposes is the front-end web application at gazetteer.lins.govt.nz. Users can search on place names, filtering by status, feature type, within various administrative areas. It provides logic for partial matches, accounts for diacritic marks, and presents all results in an interactive side panel that also highlights official names. Users can also browse the map to show all place names in a given area by panning and scrolling, and whichever way they search, the results are presented over the top of either a combined LINS topographic base map or a simplified land cover base map, including bathymetry to the edge of New Zealand's continental shelf. The information will at a minimum include a reference point, and if it's available as it is for maybe half the features in the Gazetteer, feature geometry like lines and polygons, as you can see in the title slide. In 2019, some of the enhancements we made included adding patterning to try and improve visual accessibility and user options so that people can change the colours and line weights as they see fit. This part of the system has been completely redeveloped rather than just updated like the plugin and database, so it might help to give more of an account of the development. The original web application from the system released in 2013 was a small map window embedded in the LINS website. It allowed text searches over a simplified topographic base map. This part of the system was developed externally, supported by a New Zealand IT infrastructure supplier. But it turned out the application as built was somewhat monolithic, making the enhancements we were after quite costly. This was almost a minimum viable product. Changing anything affected everything. Having been embedded on the LINS website, there are also clashes with Drupal, the open source web content system the site was built in. So, while preparing a business case for the updates we were after in 2015, a team from the provider pitched a complete rebuild based on the open source JavaScript mapping platform Leaflet. Although the development did end up a bit elongated, the end result was far superior. First, the application was put on its own 4th level domain within the LINS website. This immediately removed all the issues with Drupal, and also took a small step towards maintaining the board's identity as a separate statutory entity. It also enabled us to use the name IDs to give every name a unique URL, which has had great benefits in linking up data. The new application front end was built on Leaflet and the JavaScript, React, and Redux libraries, again, both free and open source. And for Leaflet itself, there's a wide community of users and developers creating their own modules. So being able to adopt some of these shortcutted the required development from our end. The back end of the application is built in Ruby on Rails, and this communicates with the Gazetteer database, picking up an export table using Docker to securely move the data. It also sits on Amazon Web Services and again uses Docker for load balancing. While this remains developed and supported externally, the full code of the redeveloped web application, including all enhancements, is openly published on the LINS GitHub account as part of our supply contract. And again, with this major redevelopment and through ongoing tranches of enhancements, we've created more comprehensive support arrangements. The final part of the Gazetteer system is the method of data distribution. This is managed through publication to the LINS data service, a platform developed by a third party called Coordinates and used by all of LINS. This platform is based on Amazon Web Services, which has a major service centre in Sydney, meaning the performance is excellent. And just out of interest, has received approval for a new centre in Auckland shortly. The open data ethos is perhaps expressed here in its most obvious form, because anything from new LiDAR to this year's latest aerial imagery, all official maps and charts, and the layers of information making up the products can be downloaded freely, typically under a Creative Commons attribution license. For the Gazetteer, users can download all names as a layer, with separate layers for the vector lines and polygons. Though not all follow open specifications, people can download the data in a wide range of the most common file formats, and though a little less relevant given the size of the Geographic board's data sets, all the vector and raster information can also be reprojected using the power of the Amazon cloud before served up to the users as a download. Through the platform's management functions, our layers are set up to just read the Gazetteer database daily, so the layers are refreshed if the changes are found. Our layers can be connected to as live web feature services through an API, as long as the users create a free login account, and there are change set services available to likewise identify and update just differences found on each publication. Publishing Gazetteer data to the LINS data service ensures our compliance with the relevant Australasian and international metadata and geospatial standards. Through the management functions of the platform, we can also see just who has been downloading the Gazetteer data or using it as a service. And far and away the most prolific users are those we've signed data sharing agreements with, like the international site marineregions.org. After that, as you might expect, various local government councils across New Zealand, Crown science agencies, and many engineering and consulting firms make up the power users. Moving into some of the lessons learned, you may have already gotten a good idea of them. For the initial development of the system, two major considerations were the costs for proprietary systems and licensing, and that LINS as an organisation actually possessed a great depth of knowledge and skill. Therefore, most of the system was built in-house. In the open source languages and software, there was already a great depth of knowledge in. And I wouldn't be exaggerating to point out that the original database, plugin, and export functions were all built by one exceptionally skilled person. But while years of planning and development went into the system, like the conceptual models, specific technical details, and the software, after going fully live in 2013, as you've heard, we found the support arrangements were insufficient to keep everything up to date, let alone upgrade anything, whether this meant securing the time of skilled people in LINs or the budget to contract externally. And the thing about not keeping current is that it becomes more difficult the more outdated your system becomes. Thinking about the database especially, Postgres 8.4 was almost end of life at the time our system was released. So we had to step through several versions of the software, testing everything was still intact at each stage, making the migration much more complicated. The main lessons from the development and redevelopment of the Gazetteer are almost sides of the same coin. While our relatively modular system has advantages and it does come with a potential overhead because there are more pieces of software to keep up to date. Much of our system is built on open source languages, on open source platforms, and we use more open source software to manipulate it, and they are literally free. But you need the skills, time, and money to build, maintain, and improve it. As we've rebuilt the system, these arrangements are now in place, though at an increased operational cost, including those inescapable costs like keeping the lights on. Each part of the system has to live somewhere, and it costs money to keep running, to maintain, to test things like disaster recovery, and for information security. So another aspect is the skill needed to operate such a system. The board needed a robust new system to support its functions as the times changed, and that system in turn changed what kinds of skills were needed to support the board. Our Secretariat team requires a reasonable level of understanding of how everything works and the specialist skills to operate it. These are quite different to what was required prior to 2013. All of the Secretariat has completed some formal training, like courses in QGIS, though is mostly learned through nearly a decade of using the platform. Thinking back to what I said about the plugin, while the intention was for the Secretariat to use it as an all-in-one, relying on others within LINs for more advanced needs, it often didn't quite work out this way, especially when we needed information on a more timely basis. So, to bring some more skills in-house, I, for example, have learnt enough SQL to take over the day-to-day database operations. But we are still quite operationally dependent on other people in the wider organisation, especially when we go to enhance things. Going forward, we could continue to try and upskill our staff as required. Alternatively, we could upgrade the plugin to add that more complex functionality, like reporting functions. A more significant departure could also be to look at the team structure and weigh up if somebody should actually have specialised software development, coding, and database management skills. But given the size of the team and that our role supporting the board also encompasses other skills beyond this, it might be difficult to justify. So now we're moving away from the core part of the system to the actual use of Gazetteer data, which is the whole point. Fundamentally, in New Zealand, official documents are required to use official names, and official documents are almost anything produced by government, whether data, reports, or a physical road sign. Official documents also include scientific publications and publications intended for travellers and tourists. So in this first example on the right, we have the topographic map with all Totaranui names spelled with a macron on the O, as decided by the board, and on the left, encouragingly, the relevant local government authority, Tasman District Council, likewise spells the name correctly. But here, I'm going to talk a bit more about reuse. As alluded to earlier, Gazetteer names also provide a search function in applications. In this example, for the catalogue of electronic navigational charts and digital hydrographic charts, using the Gazetteer names in the search function, it'll take you to the location and give you all charts at all scales that intersect with the chart boundaries. It also uses the linear and polygonal extents from the Gazetteer, such as in this example for Whakaari White Island Canyon. In this next example, Land Online, New Zealand Survey and Title System repository, also pulls a small extract of place names from the Gazetteer to similarly provide a search function. So here, I've just searched Ngaruawhia, and now you can see New Zealand's cadastral fabric, the property parcels in the area. Similar uses of Gazetteer data are also to refer to an authoritative source for place, not specifically compliance, to just help spatially reference records. Here, Antarctica and New Zealand have their multimedia catalogue, their photos and reports, grouped by place name from the Gazetteer. But having a national authoritative source of place names is also important for reuse by third parties who want to get things right. In early 2019, we had a meeting with Wikipedia's Wikipedian at Large, somebody sponsored by the Wikimedia Foundation for New Zealand. Not long after, the New Zealand Wikipedian community agreed on a policy to use the official geographic name for all article headings. Here, you can see Meditoto, Ship Cove, an official dual name. Thanks to the rebuilt web application, where name IDs provide a unique URL, we now have some 21,572 Wikipedia pages linking back to the Gazetteer. Wikipedia is now the third most common vector to the Gazetteer after redirects from the LINS website or from a search engine. And as Wikipedia articles are reproduced across many platforms like Google searches or Google Maps, so too are these official names. Google itself has begun more systematically ingesting Gazetteer data, particularly with a major update in early 2021 when they refreshed some of the way they depicted mapping data. Many decisions, such as adding macrons to Māori place names or for official dual names, can now be seen in Google products. Making these kinds of connections with third parties really does affect change, because if the official name is what people see on a day-to-day basis on all the things they use, it really does make it real. Some other reuse cases. In this example, we have a third-party cartographer and digital mapmaker who reuses Gazetteer data along with data from other sources, including for commercial use. Next, Gazetteer data is also used for linguistic research. Tupanaha, Matatini, and Dragonfly Data Science created new text recognition software to recognise Te Reo Māori, the Māori language, by training it against the New Zealand Gazetteer. This map shows the results of place names which do, or do not, appear to contain Te Reo Māori. You can see in this blown-up version of the map in purple areas of significant overlap between the two, otherwise with Māori in red or no apparent Māori in blue. And there's a very distinct geographic distribution. They've then gone on to use this tool for things like measuring the amount of Te Reo Māori spoken in the New Zealand Parliamentary Hansard over time. We've also had a number of researchers sit in with us at the LINS office, usually to research a particular place name, but sometimes to study an entire body. In 2019, we had a PhD candidate from the University of Glasgow, Scotland, looking at the influence of Scottish naming in Otago and Southland regions. This map shows waterways across New Zealand using burn rather than stream or river, and you can see the clear geographic distribution. So what's next for the Gazetteer system? I'll emphasise one more time that we've now put in place robust support arrangements, and hopefully this will keep software currency from getting out of hand. But the updates will still require our time to define and test. What is likely to be a big project in the near future is another rebuild of the web application. Having conducted user surveys and kept track of other incidental feedback, it is a bit mixed. The Crown Agency, Manaaki Whenua Landcare Research, use the Gazetteer for freshwater research and consider it to be easy to use. But many others, including the general public, don't find it intuitive whatsoever. We've also run into limitations of the open source leaflet platform. For example, performance is affected when there are thousands of results, and this is probably because it's browser-based. To achieve a seamless and intuitive experience we want for our users, the board will also have to meet their expectations in terms of the actual content, the data. To take one example, we've recently imported about 7,000 new entries for history in agreement with a book publisher, and will shortly be contracting an historian to begin producing more content. We also want to see the Gazetteer understood, acknowledged, and more widely used by those both that legally have to, but also more broadly. For a start, while all of government and some third parties are legally required to comply and use official names, this doesn't necessarily occur on a voluntary basis, especially when they're not aware of their obligations. So in terms of a regulatory model, you could say we'll be moving away from voluntary compliance into something more proactive, like assisted or directed compliance through education. The legal framework exists and our robust system makes it all technically possible. We just need to bring everybody on board. We can easily imagine an ideal future of machine-to-machine connections across local government, regional government, and other agencies, informing their systems and products as to what the official place names are. Across third parties, information about place names could likewise be linked up. The Alexander Turnbull Library, which holds the manuscript collections of the National Library of New Zealand, has now incorporated Gazetteer name IDs into its thesaurus. Though we wouldn't probably serve up multimedia through the Gazetteer, as more of these links are made, it does mean that cross-government and cross-institutional information about place could easily be pulled together. So with that, while our imagination and ambitions might be unlimited, and I can continue to go on with our plans, our resources and your time are not. I'm sure we'll present again to UNGEGN in the future with another chapter on the development of our system. And with that, I'll end the recorded presentation and say hello again in person and potentially answer your questions.
Did you don't ada masih mau kan? Kok ada. Di mana? Di Bukit Bunga kan?
Thank you very much, Chris, and thank you all presenters for presenting three instructive and very interesting talks. And I think we should give them a virtual clapping hand, and you can do that on the reactions, just like what I'm doing now. So please go ahead and cast your reactions. We are now going on to the next part, the question and discussion part. And I'll just share the screen again. Here, the open discussion. We still have a few minutes, so we can easily have a nice, good discussion. I'll just unshare again, and I will open the floor, and please use the hand, or possibly if you can't make use of the hand, just say in the chat that you'd like to have a comment. So I'm looking forward to the first comment. While I'm waiting, yes, we have Pete.
Hi, Peter. A pleasant good morning, good evening, good night to everybody. I'm Cecile. Peter, there's a question from Francesco Bartoli. I'm sorry if I'm not pronouncing your name properly. Peter, you may wish to have one of our panelists answer the question posed.
Yeah, it's Francesco says, thank you presenters for these interesting examples. Any of you is considering to move from OGC web feature service to the modern OGC API feature specification in order to be more API first oriented? Is there any implementation out there? I'm asking because the WFP, we are starting this approach a couple of years ago to streamline geographical names of our maintained administrative services. And would any of you like to answer that? Chris, or Pier Giorgio, or Vivienne, or
Maybe Chris can start, because they are already thinking about the API more than we are doing for the European Gazetteer, but I can add some more for Europe as well.
Sure. So for New Zealand, because our publication of our data is mostly managed through the LINS data service, which is a platform that's cross-organizational, we, working for the Geographic board, are almost end users in this respect. So most of the things like setting up the APIs and web services are handled through that system, but I'm sure I can get back to everybody on what the plans are for the near future. I know currently the data service managers are looking again at the way LINS manages data, and I'm sure they'll be keeping everything up to date with the most recent developments.
I don't work directly with geoservices, but I think they are working on it, but I'm not sure.
Yeah, maybe I can add something for Europe. For the Gazetteer at the moment, for the European Gazetteer, we are providing the information as WFS, Web Feature Service, and GeoPackage. But, and that is a big but, in Europe, there are ongoing activities from the European Commission and the European Parliament to establish so-called data spaces for specific reporting topics. So for the environment and for the transport reporting in Europe, and this is included in the so-called data strategy for Europe, as well as in the European Green Deal. And within these strategies for Europe, the APIs are the technology we have to focus on in the future years. So this is definitely something we have to deal with as a geospatial agency, but also as a data provider in general for Europe. And it will be tackled within these so-called data spaces. Thanks.
Thank you very much, all three. That was nice to see all presenters answering the one question. Peter Jordan, you had your hand up just before, so please go ahead, Peter.
Yes, thank you, Peter, and thank you all the presenters for these very interesting presentations. I would have a question, I think mainly addressing Pier Giorgio, but maybe also the others. How do you proceed with names of oceans and seas? How do you proceed with names of oceans and seas? Do you note only the international names as they are provided by IHO, by the International Hydrographic Organization? Or do you use your exonyms, the German exonyms in the German case, or the Portuguese exonyms in the Brazilian case? Or do you also show perhaps endonyms of all the riparian countries? So for instance, around the Baltic Sea, the Danish, the Swedish, the Finnish, the Russian, the Baltic, the Polish names, or perhaps even all of them. Thank you.
Thank you, Peter, for that question. I think we used the names already established in the European products, Euro regional map and Euro boundary map in that sense. And so they are the agreed names for international use and communication. So to answer your question, to avoid any conflicts, to avoid any discussion on the sea names in that sense. So we are not, as far as I know, but maybe Roman, if he's available, can provide an answer to that. We are not linking exonyms to those names. Mm-hmm. Thanks.
Thank you.
And thank you very much. I think, well, I put up my hand first, but it's I see Iman Oriebi from Egypt is also interested in asking a question. So please, Iman, go ahead and ask your question.
Okay, thank you. I will ask Pierre for for SDI degree open source. It is compatible with Arabic language or not, and also it for GeoPackages. Is it compatible with features shapes like from Esri or so what? So I want to ask of compatibility for both languages and feature classes. Thank you.
Thank you, Iman, for that question. Nice to see you. With regard to degree, I don't know if it's compatible to Arabic. I would have to ask. I think it's a German company providing this software tools. I have to check, and I will provide you with an answer to that. With regard to GeoPackage, I'm quite sure that it is compatible to ESRI and to all the other providers of GIS software. So you can implement and integrate these databases into ESRI products as well as into QGIS as an open source GIS.
Okay, thank you, Pierre, and thank you all for your presentations. Thank you.
Thanks.
Yes, thank you very much. And then I see Adriana Vescovo. Please go ahead.
Hello, thank you for all the presentations. The issue is very important. My question is for Pier Giorgio Sacchedo. And you, if I could understand, you told us you transform the features, the reference for the features in points. Which are the criterions for determination of these points for feature, for example, lines or areas?
Thank you.
Document, or I don't know.
Yeah, Adriana, thank you for that question. A very good question. Yes, there is a document. There is a specification for the Open Regional Gazetteer. It's available on the website I put onto the slides, and there you can find the principles how to deal with transferring areas, lines into points.
Okay, thank you. Thank you a lot.
Thank you. I would just refer Roman Stanifertel's question, because he replied in the chat to Peter Jordan's question. He says there's actually there are almost no names of seas in the Open Regional Gazetteer. I hope that answers your question somewhat, Peter. I would like to ask a question to Chris. I noticed that you said that each feature has an ID, which is as you'd expect, but also that each name has its own ID. Does that mean that the same name can be used to different features? Is that why you have this ID?
It's more for there being multiple names for a single physical or administrative feature. So primarily this is where a name is officially replaced. So this might be to correct the spelling, and we keep a record as another entry of what the prior spelling was. In other cases, which are rarer, there are two official names. Sometimes this is because of a political decision or a historical legacy. And there's also increasingly much more data adding to the Gazetteer original Māori place names, even if not as an official name. So thinking about the Gazetteer data as a whole, roughly 50% of names have a Māori component anyway, so they might be the official name, but in many other cases there are, for lack of a better term, European, British, English place names, and many will have original Māori names for them, and we're increasingly publishing those. So having the unique name IDs, this is useful for where names all apply to the exact same feature. It does become more complicated when there's a slight difference in perception in, say, like Māori names for the seas, which, going to the previous question, might not quite line up with, say, Te Tai o Rehua might not line up with the Tasman Sea precisely. So it's just our way of managing both history and administration.
Ah, okay, I see. Thank you very much. And then I see Bogumil Zadi. Please go ahead, Bogumil.
Hello. Good afternoon. I have a question to Pierre, because I would like to ask about the possibility of registration of changes of place names, because as we perfectly know, every day or every year we have a lot of changes of place names, and I would like to ask about the method or methodology of registration of changes of names.
Thank you very much for that question. Yeah, the two products where the national names are used for the Gazetteer, they are updated once a year. And there is a well-defined updating process where all the members of Eurogeographics are involved. So there are regional coordinators who deal with certain areas in Europe. And so every year, the national data sources are updated, and the axonyms and variants are updated by my colleague Roman Stanifertl. So that is the updating circle. At least once a year, all the data is updated.
Thank you very much. It means we have like timestamps. There is no relational database. It's timestamps for every year.
Yes. For the
Thank
product used, Euro regional map and Euro boundary map.
Thank you very much.
Perfect.
Thank you. Adriana, are you wanting to ask a question still? Because your hand is up.
No.
Oh, you're very welcome to ask a question. It's not that. Any other questions? We have 4 eager presenters here waiting to ask a question. While we're waiting for one, I can just ask to all 4. Do you have any requests from other countries to use your models or parts of your models?
I might just quickly chip in to say it's very interesting to see some of the same story and some of the same solutions with the other presentations in terms of integration of Postgres with QGIS, and the same issues with version currency a little bit. Yeah, just a comment.
Do any of you other have a comment to this? If not, we will turn on to Pavel Svoboda. Please go ahead, Pavel.
To Pier Giorgio regarding to the question of Bogumił. Are those old names which have been changed are stored somewhere in your database, so one can review older previous names of features of objects, or it is deleted and it is no more accessible to users? Thank you.
So that's a very good question, but officially we do not have a versioning of the source data. So if Eurogeographics publish a data product, and that's as I said, 2 products relying where the Gazetteer relies on, these are published once a year with a certain timestamp. That is important, for example, for the European Commission. They need one date. They can rely on statistics, for example, for Euro boundary map. But I know that older versions are stored. And so on request, I think you could get, or you might get, older versions if there is a strong request for that.
Okay, so as far as I understand, it is not possible to track these changes on a timeline, for example.
No, that would be perfect, but unfortunately that's not the case.
Something to build in a new version.
Yes, sure.
Thank you very much, Pavel and Pier Giorgio. And now I give the microphone to Wendy Shaw of New Zealand.
Thanks, and hello everyone. If I could just comment on that last question from you, Pavel. For the New Zealand Geographic Board, we most certainly do reveal and make discoverable the whole history of the naming of a particular place or feature. So that history and heritage of the naming of a place is really important to expose. So that's always there where we have it. And just to also answer or just make a comment on whether other nations have expressed an interest in our Gazetteer and the code that we have. Christopher did allude to the fact that we've got the code registered through our GitHub account. So the Philippines, I know, has expressed an interest. We've just recently had a session with some Australian jurisdictions, I think Queensland in particular. So our code is freely available if you can figure it out to anybody who wants to have a look at what we've done and reuse it for their purposes. You just have to be able to log into the LINS GitHub account. Chris?
Yep, that's all good. It is obviously developed to serve our purposes, but I'm sure it could be repurposed, especially some of the bits like the web application would be more applicable in a universal sense. Maybe the database structure will have some unique New Zealandisms in it. Thinking about the historical information question as well, I mentioned that our naming starts sort of with an honorary board in 1924, though there is a little bit of legislation prior to that. So what the board holds is an interesting mix of the surface level of place names on maps for the last century or so, and then more historical names in terms of Māori place names, and maybe there's a gap in the middle. So it's not like a complete historical data set of everything and every name that's ever been applied to a feature in New Zealand. It's more of a government official naming data set, but with more historical information added to it.
Thank you. I give the microphone on to Abdullah Alewaile. Sorry for keeping you waiting, but go ahead. Please, Abdullah, the microphone is yours. It seems Abdullah has a little difficulty in finding the unmute button. Oh, there we go.
Yes.
Please go ahead.
I was muted. I didn't notice that. I was talking alone. So,
please go ahead then.
Greetings to all. We just came out of Ramadan. We were fasting for 1 whole month. So thank you very much for this nice presentation. My question is that about the developers of these gazetteers. Are they all officials, like done through governments or through official boards or national committees or NGOs or some scholars in the universities? Like I'm talking about what we have in Saudi Arabia. We have like some developers, some scholars in the universities. They would just write gazetteers, names gazetteers, and they would be very detailed in historical backgrounds and poetry said pertaining to place names, and also interpreting also in the terminology. All these things are done by scholars who are not officials. Sometimes we have discrepancies between the official gazetteer and those scholars, and that makes some confusion for the public. I would like if somebody would, if anyone has experienced any difficulty in this and how to go about making some common ground between gazetteers developed by individuals who are not officially assigned, and about those gazetteers which are officials. Thank you very much.
Thank you. Anyone would like to answer that?
I could cover parts of the questions. So for the development of the system itself, the majority of the system is developed by officials or commissioned by government. So Land Information New Zealand, LINZ Toitu Te Whenua, is the government ministry for land information, as you might get. And it has data infrastructure people, it has developers, and it also does, across New Zealand government, there are also third-party suppliers who have sort of government preference or all of government contracts. So our system in general, the plugin we use is entirely built in-house effectively by officials. The QGIS is open source software, but we have people within the organization developing for it. Then the web application is developed by a third party, but as part of a contract from government. And then the LINZ data service is managed by a third party and developed by a third party, but again, LINZ uses it with a supply contract, as best as I understand it. For the questions on effectively third-party data, some of the information from my presentation that I cut was on challenges with third-party data. We don't necessarily have scholars producing their own gazetteers of New Zealand, but we do have an interplay between what are official names and what the public might use. So this is why I included some of the information about getting official names into Wikipedia and into Google Maps, so that we sort of get on top of that potential issue of conflict. That said, it's not perfect, and it's not like we have a semi-formal relationship with Google, for example. So it's not like there's a WFS connection or an API directly feeding names into Google. We are putting more historical information into the Gazetteer, and it's likely we'll be commissioning historians, taking a page perhaps from Australian jurisdictions with their National Place Name Survey, but I don't think we have much conflict in the way of, say, scholarly publications, just third-party or open source data conflicts.
Thank you for the comprehensive answer. Pier Giorgio or Vivienne or Graciosa, do you have comments to this?
In Brazil, we have no names authority, and we would be able to control the issue of other gazetteers. And the development of the gazetteers were made in IBGE, which is a governmental institution.
Yeah, maybe I can add something for Europe here. Of course, there are many gazetteers published in Europe from certain different data providers, but the open regional gazetteer for Europe, as I explained, is a joint effort of the national geospatial agencies in Europe. So there is official data coming from the countries, from the members, used for the gazetteer. And then for the exonyms and variant names, of course, the case is different. Roman involves the UNGEGN network in Europe for exonyms and variant names. And so there's also a backup for that. And if countries have, or if members do not sign the open license, because sometimes there is a national conflict with regard to the open open license to publish the Gazetteer as an open data set. Then in certain cases, I know that we have initially started to use OpenStreetMap as a source for that country, but that was agreed with that country. And that is so long the case until the country provides us with the license agreement to use the data, open data. Thanks.
Okay, thank you. And I think Wendy had a question, and then there's a comment from Chris Mirindalot. But I think, Wendy, did you want to say something first?
Very, very briefly, just that we try to make it very clear in the New Zealand Gazetteer which names are official. So those are the names that have been through a robust consultative process. And then within our legislation that governs place names, official place names in New Zealand, we have a compliance provision as well as an enforcement provision. So government agencies especially are actually required to use official place names. That's to help make them, you know, used. Thank you.
Thank you very much, Wendy. And then I will return to Chris Mirindalot's question. And she asked actually a little while ago, so I'm sorry I didn't see it. She asked, can any of these systems accommodate videos to display place names in sign languages? And by saying sign languages, she means that signed place names assigned by deaf communities, not place names translated into sign languages. Any comments on this or question to this?
Sure. Just the immediate answer to the question is no, not at the moment. And there's nothing planned right now. However, we do have a long-standing but sort of informal relationship with the New Zealand Sign Language Dictionary. So we do take that into account. The Geographic Board takes that into account when making decisions. So we do have an agreement on potentially creating new signs when the board decides on new place names. And if you go to the New Zealand Sign Language Dictionary, you can find, you know, the agreed signs for various place names across New Zealand, though to be fair, the board's involvement is relatively minimal. It is something definitely to think about. We're looking at adding an audio component, which has never previously been within the board's sort of remit to the Gazetteer as part of an enhancement in the very near future. But we are also looking at redeveloping the whole system, as I alluded to in the presentation, so that's something else to consider.
Thank you very much. Pier Giorgio, Vivienne, do you have any remarks to this?
Yeah, we don't have place names translated into sign language at the moment, but it's a fantastic idea.
That's the same for Europe, Pera.
Okay, yeah, I second or third or whatever it is. I think it's a good idea to start thinking about how to integrate sign language more in the geographical names question. We have gone quite a bit over time now, so I think it's about time to wrap up. Unfortunately, we had a really good discussion, so that's why I kept it running for a little while longer than was planned. But the open discussion I would now conclude. There have been questions about webinar, whether it will be made available, and it will be made available on the UNGEGN homepage. It will be found under working groups and training courses in toponymy under working groups and on the number 6 working group on training course in toponymy. And if you go to that page, you will see that the last bar is called webinars, and click that one and you will see there's one webinar already. That's the first webinar we had in August last year. And right after this session, we will upload the webinar, the video and the documents and so on, so that you can all look through it at your leisure and as you all have time to do it, and you can show it to your colleagues, especially if there's interesting aspects or aspects that relate to your national mapping agency. And with this, I would like to conclude, say thank you to you all. I must say I've steered a few meetings recently, and online meetings is always a challenge, but I must say you have been very good with muting your microphones and with asking questions in an orderly manner. So I think we should all give each other a hand for being such good meeting participants. I would like to say thank you on behalf of the UNGEGN Secretariat. Should you have any questions, you can always contact us. If you want to see more about the UNGEGN, you can go to the homepage, or also keep an eye up on Twitter to see what is going on, because sometimes we have some messages coming out there. Otherwise, thank you for today, and thank you for being so patient and sitting on half an hour more than what was scheduled. Hope to see you soon again, and bye-bye for now.
Bye-bye. Thank you very much.
Bye-bye.
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 Bye.
Bye-bye.
Bye.
Bye.
Bye-bye.
Thanks all.
Bye.
Bye-bye. Bye.